Good morning, students. Unit 5 Coordination Chemistry. Unit 5 Coordination Chemistry. In this session, I am going to teach the theories of coordination compounds. Theories of coordination compounds. Theories of coordination compounds. So already you know that Werner's theory. Okay. So Werner theory. So Werner considered the bonding of coordination complex. The bond formed between the Lewis acid and Lewis base. Alright. So the complex FeCN6. 4 minus. So example of the complex, right? So the central metal atom, so accept lone pair of electron from ligands. So accept lone pair of electron is Lewis acid. Okay, so donate lone pair of electron, so Lewis base. Okay, the bond formed between the Lewis acid and Lewis base. So consider the Werner's theory. So some of the properties can explain in the Werner's theory in coordination compounds. But some of the complex such as color and magnetic properties does not explain in the Werner's theory. Okay, so following the Werner's theory, the Linus Pauling proposed valence bond theory. Okay, the short form VBT. So valence bond theory. Okay, so that theory assumes the bond between the central metal atom and ligands is purely covalent in nature. You right? So Werner's theory, Lewis acid க்கும் Lewis base க்கு இடையில bond formation இருக்கு அப்படினு சொல்லுது. So Linus Pauling propose பண்ண valence bond theory, so central metal atomக்கும் ligand க்கு இடையில covalent bond இருக்கு அப்படினு சொல்லுது. Okay, so following the BB theory, the Bethe and Van proposed crystal field theory, CFT, crystal field theory. So that theory assumed the electrostatic attractive force occurs between the central metal atom, central metal ions and ligands. Okay, so for the ligand field theory, molecular orbital theory, okay, have been so explain the nature of bond. Okay, so okay students, so in this session we learn valence bond theory. Okay, so valence bond theory, VBT theory. Okay, short form VBT, right? So first for example oda nama assumption பார்க்கலாம். So main assumption of valence bond theory. Okay, so the valence bond theory. So according to valence bond theory, the bond formed between the central metal atom and ligands, central metal atoms and ligand, is due to the overlap of filled ligand orbitals containing lone pair of electron and vacant hybrid orbital of the central metal ion. Okay, so example பார்க்கலாம். So example, the complex FeCN6 4 minus. FeCN6 4 minus. Okay, so the outer electronic configuration of Fe, atomic number 26, so argon 3d6 and 4s2. Okay, so in this complex, 4 minus, 6 minus, so Fe2 plus. The outer electronic configuration of Fe2 plus ions, Fe2 plus is equal to, okay, so 3d6. Right? So 3d orbitals, 1, 2, 3, 4. So 3d orbital, 3d, 4s and 4p orbitals. 4s, 4p orbitals according to Hund's rule. Right? So the same energy level orbitals contain unpaired electron first, then paired. So 1, 2, 3, 4, 5, 6 electrons. Are you right? So Fe2 plus electronic configuration, right? The Cn minus. So Cn minus is a strong field ligand. Ligand. Okay. So nature of ligand is must. The donor atom carbon, nitrogen and phosphorus contain ligands are strong field ligands. Strong field ligands. The other ligands are weak field ligands. The strong field ligands causes the pairing of 3d electrons in the metal. Right? Okay students. So ligand strong field ligand இருந்துச்சு அப்படினா so இந்த 3d orbitals இருக்கக்கூடிய unpaired electron pair up பண்ணும். Suppose ligand weak field ligand இருக்கு Cl minus, so Cl6 அப்படி சொல்லி இந்த இடத்துல இருக்கு அப்படினா weak field ligand அது pair up பண்ணாது. ஓகே, சோ அப்ப pair up பண்ணிச்சு அப்படினா பாருங்க Fe Cn6 4 minus, so 3d orbital 1 2 3 4 5 3d 4s and 4p orbitals, right? So 3d 4s and 4p orbitals. So pair up strong field ligands, okay, causes the pairing of 3d electrons in settled metal atom. Okay, so 6 electrons, 2 4 6 electrons, right? So coordination number is 6. The ligands contain lone pair of electron. That lone pair of electron donated to the central metal vacant orbitals. Okay, so it's a hybrid orbital, vacant hybrid orbitals. Okay, so coordination number 6. So 6 ligands, Cn minus 1, 2, 1, 2, 3, 4, 5, 6. Cn minus, Cn minus, Cn minus, Cn minus, Cn minus, Cn minus. Right? So the hybrid orbitals. The hybridization is D2sp3 hybridization. Right? So the hybridization is D2sp3 hybridization. D2sp3 hybridization. So coordination number 6. So geometry octahedral geometry. Okay, so the magnetic moment. The magnetic moment can explain by using the spin-only complex formula. So mu s is equal to square root of n into n plus 2 Bohr magnetons. N into n plus 2 Bohr magneton. So n is a number of unpaired electrons. Are you right? So magnetic moment value. So number of unpaired electron is 0 in this complex. Okay. So mu s is equal to 0. Are you right? So magnetic nature. So para or dion. The unpaired electron present in the complex. That complex is paramagnetic. Okay. The all electron is paired. So diamagnetic in nature. So diamagnetic in nature. Are you right? Okay. So இது ஒரு சிம்பிள் எக்ஸாம்பிள் வேலன்ஸ் பாண்ட் தியரிக்கு. இப்போ நம்ம அசம்ப்ஷன் பார்த்தோம் அப்படின்னா இது அண்டர்ஸ்டாண்ட் ஆகும். ஓகே, சோ the first point, the main assumption of VBT. The main assumption of VBT. Okay, the first point, point number 1. So already you know that. So according to valence bond theory, the bond formed between the ligands and central metal atom, okay, is due to the overlap of filling orbitals containing ligands in lone pair of electron and central metal atom. Okay, so vacant hybrid central metal atom. Okay, so first point, assumption, main assumptions, 5 mark questions. Okay, listen, the ligand and metal bond. The ligand and metal bond is covalently in nature, right? So covalent in nature. Okay, students, the first assumption, the ligand and metal bond is covalent in nature, right? The sharing of electrons between the central atom. Okay, so vacant hybrid orbital in metal ions and with the ligands. Okay, the sharing of electrons between the ligands and central metal ions. Okay, the electron provided by the ligands. The electrons provided by the ligands. Okay, so the sharing of electrons. So covalent in nature. Sharing of electrons is covalent in nature. So first point. Okay, so the second point, each ligand should have at least one filled orbitals containing lone pair of electron. For example, ligand amine NH3. Okay, so the nitrogen outer electronic configuration 2s2 2p3, 2s2 2p3, right? So 2s2 2p3, 2s2 2p3. Okay, 3 hydrogen hybridized with the nitrogen atom. Okay, so one pair electron, so one lone pair of electron presents in the ligands amine. Okay, so such each ligand should have at least one completed filled containing lone pair of electron, right? So each ligands having lone pair of electron. So third point, in order to accommodate the pair of electrons donating by the ligands. In order to accommodate the electron pairs donated by the ligands, the central atom presence in the complex provide the required number of vacant orbitals. So required number of vacant orbitals or the coordination number. The coordination number equal coordination number of vacant orbitals. Okay, students, that point. So ligand, so electron pair donate பண்ணுது. அந்த donate பண்ற electron accept பண்றதுக்கு இதனுடைய coordination number என்னவோ அந்த அளவுக்கு இங்க vacant orbital இருக்கணும். Okay, so இங்க coordination 6, அப்ப 1 2 3 4 5 6 hybrated orbitals central metal ions. Right? So இதுதான். So the the coordination of equal number of vacant orbitals. Equal number of vacant orbital. Okay, so coordination number. So coordination number க்கு ஈக்குவலா அதுக்கு சென்ட்ரல் ஆட்டத்துல hybrid orbitals, so vacant hybrid orbitals இருக்கணும். coordination number க்கு ஈக்குவலா. Okay, so இது third point. Okay students, the fourth point. Okay, so fourth point, this vacant orbital of central atom. Okay, so இப்ப பாத்தீங்க அப்படின்னா இது ஹைபிரிடைஸ் ஆயிடுச்சு. அதுக்கு முன்ன இந்த மாதிரி இருக்கும். So 3D, 4S, 4P, right? So strong field Ligon 2, 4, 6. This vacant orbital of central metal atom. Okay, so this vacant orbital of central metal atom undergo hybridization. Undergo hybridization, the process of the mixing of atomic orbitals. The mixing of atomic orbitals, Ligon, cyanido, the atomic orbitals, donor atom carbon. Okay, so with the central metal atom. Okay, the process of mixing of atomic orbital of comparable energy to form a equal number of new orbitals. The coordination number is 6. The 6th new orbital D2sp3 is formed. That orbitals are called hybridized orbitals with the same energy. You write. So the vacant orbital. Fourth point, the vacant orbitals of central metal atom undergo hybridization. Okay students, so the central metal atomல இருக்கக்கூடிய vacant orbital தான் hybridizationல involve ஆகுது. அப்ப hybridization அப்படினா என்னன்னா the process of mixing of atomic orbital of comparable energy. So equal or more or equal energy இருக்கக்கூடிய two atoms. So comparable energy, the mixing of atomic orbitals. The mixing of atomic orbitals of comparable energy to form the equal number of new orbitals. Equal number of new orbital is called hybridized orbitals with the same energy. Are you right? Okay, so D2sp3 hybridized new orbital is occurs. So fourth point. The fifth point. The vacant hybridized orbitals of the central metal ions. The vacant hybridized Fe 2 plus, right? So the vacant hybridized orbital of the central metal ions linearly overlap with the filled orbitals of the ligons. So they linearly overlap. Cn minus Cn minus right? So the vacant hybridized orbital of the central metal ions linearly overlap with the filled orbital of the ligons. to form the coordinate covalent sigma bond. The coordinate covalent sigma bond. So right. So the ligand, fill the ligand atom, coordinate covalent sigma bond. Coordinate covalent. The coordinate covalent sigma bond. Okay. So the vacant hybridized orbitals of the central metal ion linearly overlap. Okay. So near both linearly overlap with the filled orbital of the ligands. So in the hybridized orbital, central metal hybridized orbital filled ligands orbital linearly overlap ஆகும்போது நமக்கு coordinate covalent sigma bond form. Okay, so ligand electron donate பண்ணி covalent bond form ஆகுறதுனால இதுக்கு coordinate covalent sigma bond. Are you right? So the fifth point, the vacant hybridized orbital of the central metal ion linearly overlap with filled orbitals of the ligands to form a coordinate covalent sigma bond. You right? The sixth point, very important point. The sixth point, the hybridized orbitals are directional. The hybridized orbitals are directional. The hybridized orbitals are directional, and the orientations of space gives a definite geometry of the complex cause. Okay, so the hybridized orbital directional in nature. So orientation, orientation on the space. Okay, so definite geometry form. So hybridized orbital மட்டும்தான் definite geometry form ஆகும். இப்போ all the complex are directional in nature. Okay, so complex ion undergo hybridization. The complex ions undergo hybridization. So all the complex are directional in nature, having definite geometry. For example, the coordination number, right? So geometry, coordination number, geometry. Okay, hybridization next is geometry. Hybridization and geometry in examples. Okay, students, the coordination number is 2. Already you know that coordination number. So coordination number 2, the hybridization is sp hybridization. 1s, okay, 1s, 1p. So involved in the hybridization process. So sp hybridization, the geometry is linear. Linear geometry. Example, CuCl2 minus CuCl2 minus linear. Okay, so copper linear overlap. C. So linear, right? sp hybridization, linear geometry, and coordination number 3, sp2 hybridization. sp2 hybridization. So trigonal planar. So example, mercury ion minus. So trigonal planar geometry, Hg. Okay, so I minus. Trigonal planar hybridization, sp2 hybridization. So coordination number is 3. So sp2 hybridization, trigonal planar. Okay, so next coordination number 4. Okay, so the coordination number 4, the different 2 hybridization is occurs. The ligand is strong field ligand DsP2 hybridization. Okay, the ligon is weak field ligon. The hybridization is sp3. sp3 hybridization. Okay, so does not depends upon the strong field and weak field ligon. Okay, so depends upon the ligon nature and oxidation state of central metal ion. Okay, so outer electronic configuration are also. So இங்க strong field weak field ligand வச்சு மட்டும் நாம DsP2 sp3 எக்ஸ்பிளைன் பண்ண முடியாது. நம்ம நெக்ஸ்ட் கிளாஸ் அத பத்தி பாப்போம். ஓகேவா? சோ சென்ட்ரல் மெட்டல் ஆட்டத்தினுடைய ஆக்சிடேஷன் ஸ்டேட், அதனுடைய வேலன்ஸ் எலக்ட்ரான் அதெல்லாம் வச்சு தான் இது சேஞ்ச் ஆகும். சோ DsP2 வந்தா ஜியோமெட்ரி DsP2 ஓகே ஸ்கொயர் பிளேனார். Square planar geometry. Okay, so square planar geometry example NiCN4 2 minus. Okay, so geometry square planar. Nickel 1 2 3 4. Okay, so Cn minus Cn minus Cn minus Cn minus. So directional image. A square planar. Suppose the coordination number 4, the hybridization is sp3 tetrahedral geometry. Tetrahedral geometry. So example, nickel Cl4 2 minus. Nickel Cl4 2 minus, right? So nickel 1 2 3 4. Nickel Cl minus, Cl minus, Cl minus, Cl minus. So tetrahedral geometry. Tetrahedral geometry. Okay. So students, நல்லா மைண்ட்ல வச்சுக்கோங்க. இத வச்சு தான் நம்ம இங்க எக்ஸ்பிளைன் பண்ண முடியும். Okay. So coordination number 6. Coordination number 6. Ligon strong field ligon. So hybridization D2 sp3. The geometry octahedral. Okay. So next. So coordination number is 5. Coordination number 5, so DsP3 hybridization 3 4 5. DsP3 hybridization, so triconal bipyramidal system. Triconal bipyramidal. Triconal bipyramidal section. So example FeCO5. Ligon is strong field ligon. Okay, the triconal bipyramidal structure Fe 1 2 3. It's a triconal planar. COC. So triconal bipyramidal structure. Triconal bipyramidal structure. Okay, so next the coordination number 6. Okay, so 2 variable hybridization is occurs. Okay, so D2 sp3. The ligon is strong field ligon. The hybridization is D2 sp3. Okay, so when the strong field ligons causes pairing of 3d electrons in the metal. Okay, so the hybridization start in Nd, n-1d orbital, 3d orbitals. Okay, so suppose the ligon is weak field ligon, that does not pairing of 3d electrons in metal. Okay, so the d orbital does not pairing, the hybridization starting from 4s to 4d orbital. Okay, so sp3d2 in strong field ligon, the hybridization occurs. The hybridization undergo n-1d orbital. In weak field ligon, the hybridization occurs undergo nd orbital. sp3d2. Okay, so for the same geometry, octahedral. The coordination number 6, the geometry is octahedral. Okay, so D2 sp3 hybridization or sp3 D2 hybridization. The geometry is octahedral. Okay, so example for strong field ligon. So the same example Fe Cn6, coordination number 6, 4 minus. Okay, so the example of sp3 D2 hybridization. weak field Ligon. Cl6 4 minus. Weak field Ligon. Okay, so same geometry. The octahedrals geometry Fe. Octahedrils. Okay, so Cl minus, Cl minus, Cl minus, Cl minus, Cl minus, Cl minus. Okay, the hybridized orbitals are directional. The hybridized orbital are directional. So give definite geometry. Right? Okay, students. The seventh point in an octahedral complex. Okay, so in an octahedral complex, okay, the seventh point in an octahedral complex. In an octahedral complex, the n minus 1d orbitals. Okay, so 3d, 4s, 4p. So 3d, 4s, 4p, 4d. 3d is a n minus 1d orbital. 4d is a nd orbital. So n is a principal quantum number. Okay, so n minus 1, n equal to 4. N equal to 4. 4 minus 1, 3d. 4s, 4p. So n 4d orbital. Okay, the n minus in octahedral complex. So listen, students, in octahedral complex, the n minus 1d orbitals involved in hybridization. The n minus 1d orbital involved in hybridization. So for example, the FeCN6 4 minus, the hybridization involved in n minus 1d orbital. Right? So n minus 1d orbital involved in the hybridization. That complex are called low spin complex. Low spin complex or spin paired complex. Spin paired complex or inner orbital complex or inner orbital complex. Or inner orbital complex. Okay, students. So n minus 1d orbital strong field ligand இருந்தா so pair ஆயிடுச்சு அப்படின்னா nd n minus 1d orbital. So 3d orbital vacant orbital ஆயிடும். hybridization இங்க இருந்தே ஸ்டார்ட் ஆயிடும். அப்போ hybridization இங்க இருந்து ஸ்டார்ட் ஆயிடுச்சுனா அதுக்கு inner orbital complex அப்படினு. Okay, so n minus 1d ல ஆரம்பிச்சா inner orbital complex or spin pair பண்ணிருந்தா அதனால spin pair. So pair of electrons clockwise and anti-clockwise directionல spin ஆகக்கூடிய 2 electrons ஒரே இதுல இருக்கும். அதனால spin pair complex or low spin complex. Low spin complex. Okay, so இதுலயே full ஆயிடும். Suppose இது weak field ligand இருந்துச்சு அப்படினா இங்க இருக்கக்கூடிய 3d electrons. So for example Fe Cl6 4 minus complex. Okay, so same oxidation state, right? But the ligand is weak field ligand, does not pairing of 3d electrons in the metal. Okay, so 1 2 3 4 5 6 does not pairing of electrons. Okay, so only vacant orbital starting from 4s orbital to 4d. Okay, coordination number 6. So 1 2 3 4 5 and 6. The nd orbitals involved in the hybridization. Okay, so 6 Cl minus 1 2 3 4 5 6. The hybridization is sp3d2. So So weak field ligand, the hybridization is sp3d2. In strong field ligand, the hybridization is d2sp3. Okay, so the nd orbitals involved in the hybridization, that complex are called high spin complex. Okay, so low spin, the high spin complex. High spin complex or spin free. Spin free. Okay, one direction, clockwise direction only. The spin free complex. Okay, or outer, ND, outer. So inner and outer. Okay, so outer orbital. So okay, students, the octahedral complex n-1d orbitals. n-1d orbitals involved in the hybridization. That complex are called inner orbital complex or spin pad complex, spin pad complex or low spin complex. The nd orbitals involved in the hybridization, that complex are called outer orbital complex, high spin complex. Okay, so low spin, high spin complex or spin free complex. Okay, so 7th point. Next, the 8th point. The hybridized metal ion. The complex of the hybridized metal ions contain unpaired electron. Okay, so that complex 1, 2, 3, 4, 5, 6. Okay, that complex contain unpaired electron, but that complex contain no unpaired electron. So all the electrons are paired. So strong field ligand, so weak field ligand. Okay, so that the complex contain unpaired electron. So paramagnetic in nature. Right? So all the electrons are paired. The complex contain paired electrons. Paired electrons are called diamagnetic. Diamagnetic in nature. You right? So they attract the magnetic field. The complex attracts the magnetic field is paramagnetic. Okay, so no magnetic attraction is diamagnetic. Okay, students, the 8th point, the hybridized orbital. The hybridized orbital contain unpaired electron. That complex are called paramagnetic complex. In paired electron, diamagnetic complex. Okay, so 9th point, the carbon, the donor atom, carbon, nitrogen, phosphorus contain ligands. So the filled orbital having ligands Cn minus, CO, carbonyl, okay, NH3, En are strong field ligand. Other ligands are weak field ligands. Okay, so 9th point. And 10th point, the 10th point, okay, the greater the overlapping, the greater the overlapping between the ligand atom and the greater the overlapping between ligand atom and the hybridized central metal atoms. The greater the overlap between the ligand atom and the hybridized central metal atom, so greater is the bond strength. bond strength. Greater is the bond strength. Okay, so number of overlapping increase ஆகும்போது bond strength increase ஆகும். So number of overlapping, so 2, 3, 4, 5, 6. Okay, coordination number 2, 3, 4, 5, 6. To increase the number of overlapping, 2 to 6, 2 to 6, the bond strength are also increased. The bond strength are also increases. Okay, students. So main assumption of valence bond theory பார்த்தோம். Okay, so இதை யூஸ் பண்ணி next classல இப்போ நம்ம ஒரே ஒரு எக்ஸாம்பிள் மட்டும் பார்த்தோம். ஒரே ஒரு strong field gun மட்டும் நிறைய எக்ஸாம்பிள்ஸ் வச்சு இந்த தியரியை நம்ம next class வந்து எக்ஸ்பிளைன் பண்ணலாம். ஓகேவா? சோ அடுத்து அதோட லிமிடேஷன்ஸும் பார்த்துக்கலாம். Okay, so thank you students. We'll meet next class.